Let's continue now with the normal distribution. Section 13.6. This is part 3. We ended with this example of IQ, where a student's IQ landed exactly one deviation above the mean, giving 84% of the students an IQ below that individual and 16% above that. Well, not everything, as we said, will land there, but we have a table that will provide us the values for other z-scores that are not on this chart that we're looking at. Okay, so what I want to do first is look at this particular individual we talked about before, because as you can tell, I've used his rounded values here, 68, and I've terminated the decimals. So we're going to use a little more accurate table now to look up even this example here. For this particular person, the z-score is positive 1. Positive 1.00 to be precise, because they are exactly one standard deviation above the mean on this particular situation. So we have in the book and on MyMathLab, they will provide you these tables. Let me assure you that on the test, you will also be provided these lookup tables. You are not required to put the lookup table on your note card or memorize it, okay? Now, these tables allow us, I'm showing you both, they're on 2 pages in the textbook side by side. Page 823, if you want to look in your textbook, you would do that by going to the multimedia feature and look up your textbook. That's one way. Our chapter contents is another. When you look on the table, it's going to always tell you the percentage that is below the value you're looking up. This is the table for z-values that are negative, below 0, and this is the table for z-values that are positive, greater than 0. Since we have a positive z-value, you will want to use this table, okay? And to use the table, we need to look up our z-value. In this particular one, we're going to use a z of, here, let me use a different copy of this for you. We said the z for this individual is one deviation above the mean, exactly one. So these start with 0.0, 0.1. We need to go down until we see 1.0. There's 1.0. Okay, and the top tells us the numbers that come after the decimal point. So we have 1 point, in this case 0, 0, and the first column is the 0, 0 column. So we select this score, which says 0.8413. So exactly 84.13%, if we wanted to go back here and use the lookup table, on the table to answer this, we would say 84.13% will be below that, because the z-value gave us a score of 0.8413 on the lookup table. Okay. And again, this is the table that we'll need to use when we don't have the nice cutoffs for these figures. Okay. So that works for the things that are less. So this is this is the lecture note that needs to come next, and it says how to use those tables. So let's go over that real briefly. To determine the percentile between any two values, draw the diagram of the normal curve. First, I want you to draw a sketch. And indicate the area or the percent to be determined. And think through where you're going to look for the value. So suppose it's right here and you're wanting the percent that's below that cutoff. What percentage would be below that? Use your formula to convert to the given z-score. Okay, so the first thing they want us to do is to draw the graph. Okay, draw the diagram. Second thing we're going to do is find the z-score. And you may want to put these steps on your note card or show an example problem or two. And then third, we're going to look up the percent on the table. Look up the percent on the table. And again, on MyMathLab, there will be a table that you can click on and open, select and open it on the MyMathLab problems, and I will provide the table on the test. It will make the test seem a little long too, by the way. When finding the percent of data to the left of a negative z-score, so if you have a negative z-score over here, and you want the values to the left, you use the table that I showed you a second ago, this one. that shows the z-value on the left. Okay, if you have a z-value that is a positive, okay, so that was for negative z, this is for positive z. In other words, the z-value is to the right of the mean, you use the other table. And they will both be provided on the test. When finding the percent of the data to the right of a z-score, so suppose they ask you to find this part out here on the right. The table only tells us what's on the left. We're going to start by taking 100%, which would be the whole curve, and subtract the part that's on the left by looking that up on the table. And what's left will be the part that we want on the right. Okay, so you take the whole thing and you subtract off the part you don't want, and that leaves what you do want. Okay. And finally, we're going to do examples with all of these in a minute. You can use symmetry. You could use the fact that if the cutoff is over here and you want what's above it, that would be the same as looking at a negative z-value, the same negative z. So suppose this was a 2.35 z-value. We could actually use the table by looking up a z equals negative 2.35 because the area below this will be the same as the area above the positive. Okay. And if that doesn't make sense to you, do it the other way and take the 100% and subtract the part that you don't want. When finding the percent of data between two scores, okay, now this is kind of the tricky one. Subtract the smaller percentage from the larger percentage, okay? They make a very simple rule. Subtract the smaller percentage from the larger percentage. So if you want the area between this cutoff and this cutoff, you're going to look up this z-value and get the percentage. That will be the percentage to the left of it. This value and get the percentage. That will be this percentage to the left. And you take the larger one minus the smaller one. Subtract the smaller from the larger. Okay? Now, this is going to make more sense when we do an example, so let's go ahead and do that. Assume that the mathematics scores of the SAT are normally distributed with a mean of 50 and a standard deviation of 100. Okay. So I'm going to draw myself a little curve. I think I better give myself a little bit more room below it, but oh well. And it says the mean is 500 and the standard deviation is 100. Okay. This is my mean X bar. What percent of students who took this test have a mathematics score below 500? Okay, they ask us to find what percent. All right, go back to the steps that we had a second ago. First of all, we need to approximate where that's going to land on the curve. 550. Here's 500. We know that if we went one deviation above, that would be 100 above that. That would be 600. So it's going to be right in here. We can predict that the z-score would be not a whole, but half, a positive 1/2. But let's, first we do the graph, and we want to know what percent of students who took the test have a score below that. So once we place 550 on the graph right there, we want the percentage that have a z-score below that, so we're wanting this region down here, right? We have a positive z-score. Okay, the first thing was to sketch your graph. The second thing is to calculate your z. To get the z, you use your data item, that's 550. Subtract the mean, which is 500, and divide by the standard deviation, which is 100. So I have 50 over 100. Divide that on your calculator. 50 divided by 100 gives us a 0.5. And it's understood that there's another 0 behind that 5, right? There's nothing after that. So when we look it up, we'll be looking up 0.5. So the second step was to calculate the z. The third step is to take your table and to choose the right table and to look it up. Okay? This table is for negative z values. That is not the one we want. This is the table for the positive z values. That is the one we want. And so we're going to look up 0.5, there's the 0.5 right there, and we want 0.50, that would be right here. It's going to be 0.6915 from the table. Okay, now the question asks us what percentage. So our final answer needs to be multiply this by 100 to put it in percentage form. 69.15% of the students have an SAT score below 550. Good. Okay, let's do the next part. What percentage of students who took the test have a math score above 650? Okay, so I'm going to draw myself another little curve here. Kind of imagine. I know that the mean is still at 500 on the SAT, and there's going to be 600. Each of these goes up by 100. So 650 is going to be right about here. Okay, that's going to be 650. And I want what percent of students who took the test score above that. We want this part down here. Above that. Okay, so now that I have a general idea of what the graph looks like, I'm ready to go ahead and calculate the z-score for this. And it should be a positive. We take 650 minus the mean, which is 500, and we divide by the standard deviation, which they told us was 100 for the whole problem. So I get 150 divided by 100, which gives me positive 1.5. Again, it's a 50 when we look it up on the table. Okay, so now we want to use the table. And we're going to look up z equals 1.50. And it's a positive z. Now remember, if you wanted to, since you could make the mirror image and look up a negative 1.5 and see what you get down there, but I'm just going to look up the positive value. Remember that when I look it up, and here's the tricky part, remember that when I look up the table, it's going to tell me the part that's below that. It's going to give me this bottom part. Okay, so I'm going to look up 1.50. Here is the chart that we need. And we're going to go down to 1.5 right here. 1.50. These keep working out to be 0. I hope we get one that isn't. And I get 0.9332. 0.9332. Okay, let's write that down. Now that is the part that's below this. Remember, we changed this to a percentage, and we take 100% minus the part that's below, which is the 93.32%. And that's going to equal the part that's to the right. 100 minus 93.32 gives us 6.68% above that particular SAT score. Good. Now, just for the heck of it, let's look up z equals negative 1.5 and see if the symmetry thing would work. The theory is that the percentage up here should match up with the mirror image by looking up negative 1.5, what's below it down there. So now we finally get to use the negative table. We're going to look up negative 1.5, which is right about, ooh, this one's kind of backwards, negative 1.5. And that gives us, yes, I'm on the right one, 0.0668. Which, if we multiply by 100, sure enough, it's the same thing, which we knew it would be. Okay, good. And finally, the last one's going to be the trickiest. I think I might even get another piece of paper for that. What percent of students who took the test have a score between 550 and 650. Okay, so it's interesting that they chose those. Very obvious that it was on purpose. We know we've got these normal cutoffs over here, and the scores that we're interested in are 550, which we looked up before, right? It's right in here. 550. And at 550, do you remember that the z in part A was 0.50? Okay, that's what we got in part A. We did this already. That was the z value. And over here, where 650 is going to be between 600 and 700, right about here. 650. And it had a z value of 1.50. And they want to know what percentage of the students have SAT scores between that range, in that range. Okay, now if you remember a minute ago, we simply need to look up both of these on the table, and they're both positive z values, so we use the table, the lookup table that looks like this, right? We look them up, and we've already looked them up, right? When we looked up the first one, we get a 0.6915, and we looked up this one, we got a 0.9332. Okay, we looked those up previously, and it said we're going to change them now to percents and take the larger one. As a percent, this is 93.32%, and as a percent, this is 69.15%, and we simply take the larger one and we subtract the smaller one. And the difference will be, grab your calculator, 24.1%, oh sorry, 0.17%, 24.17% have an SAT, I guess it should be ASAT, that doesn't sound right, between 550 and 650. Okay, 24.17%. Good. All right. So now we need to do another type application besides just the SAT. Continue to use the table. The next example, example 5, has to do with battery warranties. The warranty on a car battery is 36 months. So this particular battery has 36-month warranty. If the breakdown time of the battery are normally distributed, we will always say that on this section, with a mean of 46 and a standard deviation of 8 months, determine the percentile of batteries that can be expected to require repair or replacement under the warranty. Okay, let's draw a curve and think about this situation. The average goes in the middle, and the average is supposed to be a mean of 46 months. Okay, and the standard deviation is 8 months. Make the 3 cutoffs below and above for the standard points to give us our references. And the standard deviation is 8 months. Okay, this is the mean. And we're interested in the warranty here. Anything that breaks down, the battery breaks down before 36 months, they have to replace it. So they care what percent they're going to have to replace in terms of determining the price for the insurance for the batteries and so forth. So 36 months is going to definitely be over here somewhere. And every time we go down by 8. So we'll take 46 and subtract 8. This cutoff would be 38 months. And then we subtract 8 again. This cutoff would be 30 months. So we can tell that the warranty is going to last to the 36-month point, which is going to be somewhere around here, right? So I'm going to call that 36 months. That didn't write very neatly. Sorry about that. Let's see if I have a way to fix that. No, that's not going to be it. 36. Okay, 36 months. There we go. And the question is, what percent can be expected to require repair or replacement under the warranty? So if they break down before that, or up to that, so this is the region we're wanting to know about. What percent of the batteries break down before the cutoff point? After that, you've got to pay for your own battery, okay? So we've drawn the curve, and now we want to get the Z value, the Z score. So we take the data value that we're using, which is 36 months, minus the average, which is 46 months, and we divide by the standard deviation, which is 8. Okay, that's going to give us a negative 10 divided by 8, and we keep these in decimal form, which will give us a negative 1.25 as the Z-score. Okay, so once you've calculated the Z-score, you look it up on the table. It's a negative Z-score. So we want the table for looking up negatives. And at the top of the table it says, table of areas to the left of Z when Z is negative. So it will help you at the top of the table. And we need to look up when Z is negative 1.25. Oh, thankfully we finally have to really figure it out. Okay. So we're going to look up 1.25. So I'm going to go down here until I see 1.2. Right there is a 1.2. And I'm going to go down. There's the 1.2. I think I'll get a straight edge if I can pick it up. Okay, there's the 1.2. There we go. And then I need to find the column that's the 0.5. This is 0.00, 0.01, 2, 3, 4, 5. So I come down the 0.5 column, and this is the value that I'm going to want right there. Negative 1.25, 0.1056. That's the percent below it. So we multiply this by 100, and we find out that 10.56% wear out or need repair or replacement under the warranty. And that's what they asked us to figure out. Good. 10.56%. Okay, one more example and we'll be done with this section. It's kind of a long one. It's a big, important section. Grading on a normal curve. Professor Snape marks his class on a normal curve. Those with Z-scores above a 1.8 will receive an A. Those between a 1.8 and a 1.1 will receive a B. Those between a 1.1 and a negative 1.2 will receive a C. Those between a negative 1.2 and a 1.9 will receive a D. Those under a negative 1.9 will receive an F. Determine the percent of grades that will be awarded. A, B, C, and F. A, B, C, D, F. Okay? So we need to draw this thing. We're talking about Z-scores now, and Z of 0 is right in the middle because it is no deviations from the average. Now, the first thing they tell us is those with a Z-score above a 1.8. Okay, we don't really care where 1.8 is. Just put it on your graph right here, and we'll call this a 1.8. Those with Z-scores above this will receive an A. So let's go ahead and look that up before we go any farther. If we can either look at 1.8 and take 100% minus that value, or we can look up a negative 1.8 because of the symmetry. Remember we did that a minute ago. I'm going to look up a negative 1.8, and that will tell me what lies below the 1.8, which will match up with a positive 1.8. So negative 1.80, and I will look this up for you, and you can trust me that I'm looking it up correctly. When I look it up, I'm going to get 0.0359. So 3.59% get A's. So far, so good. Okay, now we have to look at the B's. He's going to give a B to people who have a Z-score between a 1.8 right there and a 1.1. So 1.1 is going to be somewhere, I don't know, right about there. It doesn't matter. It doesn't have to be to scale to get it. 1.1. And I'm going to color this red. Sorry about the two of you who have trouble with colors. I'm telling you that's red. 1.1 is that Z-score, and we want the section right in here is the part that gets the B. Now I kind of regret looking this up this way. So if I looked up the whole part by doing symmetry from here up and I subtracted that off, it would give me the same thing. Or since these are both positive z's, I'll look them up. That's what we said we were going to do. So I'm going to go down here to work this problem, and I'm going to look up a z of 1.8, positive 1.8 on the positive table. And so I'm pulling that table out, and I'm going to look up a 1.8, and it's a 0.9641, which we know is 96.41%. And I'm going to look up at the z of 1.1, which is 1.10, 8643. 0.8643. So that's an 86.43%. And it said to take the two z-scores and subtract the smaller one from the larger one. So now I can subtract, find the difference here. And I'll get a 10 point. Wait, is that right? Hold on a second there. Did I look up these? Let me double check my value. 1.1 is a 0.8643, and a 1.8 is a 9641. Okay, so I'm going to have 96.41 minus 86.43. Oh, I did my subtraction went the wrong direction there. It kind of got me off. Okay, so I subtracted that. I get a 9.98% get B's. 9.98%. Okay. Now we have to figure out the C's. And it said in the problem that the C's will be given to people whose Z-scores are between a 1.1 right here, where we cut off on the B's, and a negative 1.2 right about here. Negative 1.2. Okay, so this is going to be the C range. This was the B. Right. Okay, for the C range, I take the two Z-scores right here, and I look them up. Okay, so I'm going to look up a 1.1 as my Z-score. And when I do, I've already looked it up, so let's cheat. 0.8643, which gives me 86.43% there. And then I look up the Z-score of negative 1.2. And let me look that up for you. Negative 1.2 is a 0.1151. In other words, 11.51%. Okay, so I'm going to subtract that. 86.43 minus 11.51 gives me 74.92% get C's. Okay, now we're ready to look at the D's. Oh my gosh, this is long, isn't it? Between the negative 1.2 and the negative 1.9, we'll put it right about here, close enough. Negative 1.9. Okay, so now I have to do these two values. Coming down here to do those. So I'm going to look at negative 1.2, which I looked up a minute ago. I'm just going to write this as a percent. We're wearing out here, 11.51%, because I looked it up a second ago. And now I look up the z of negative 1.9. These are my z's. Okay, and looking up z of negative 1.9. 0.0287. 0.0287. So I'm writing that as a percent. And I'm going to subtract this. 11.51 minus 2.87 gives us 11.51 minus 2.87 gives us 8.64%. Get D's. Okay. So I should probably have colored that blue because I worked it with a blue pen down there. And finally, we're ready for the F's. Yay! These below this are going to be F's. So all I have to do here is look up the negative 1.9. And I looked it up a minute ago and I got to 2.87. So 2.87% get F's. And that concludes our last example of normal distribution. This example is not hard in terms of I want you to be able to understand all of it. On a test, I wouldn't have you calculate so many parts because it would take long, okay? Longer than you would necessarily have for one problem. Okay, that concludes 3.6, and I'll see you soon.